I have many memories of us having a early prototype rocket at the build site where we, needed a week of time in order to integrate all of the last components before we physically sent it on the road down to the launch site in order to fire up the engines or pressure test the vehicle for the first time. And Elon would kind of pose challenges to the team that seemed, physically impossible. You're telling me you need 7 days. There needs to be a rocket on the launch pad tomorrow morning at sunrise. Like, go.
Welcome back to our verifiably great Wild Heart Operator series. This series is dedicated to servicing the lessons from verified world-class operators, the Australians and New Zealanders at the forefront of building generational companies. From product to manufacturing, engineering to marketing, each of these conversations is a masterclass in how someone at the top of their game gets it done. What does it take to launch a never-before-seen reusable rocket into space? Few people know. What does it take to build a facility that produces cultured meat? One person knows, and that's Ines Lizaur. This episode uncovers Elon Musk's qualities as a leader, the principles that make SpaceX special, the heuristics, challenges, insights, and stories from one of the great operators to grace the Aussie ecosystem. If you enjoyed this episode and want to listen to the other gems that we have planned over the coming season, we would be super grateful if you would subscribe to the podcast to help other Wild Hearts find it too. And finally, if you're a founder right at the beginning looking for investment, my LinkedIn DMs are waiting for you to say hi. And with that, over to the episode. Let's start at day one. You're a build reliability engineer at SpaceX in LA. Describe what it was like.
It was certainly nerve-wracking.
Yeah.
To me, SpaceX was a company that, you hear a lot about it. You hear about Elon and everything they're doing. And I certainly had a little bit of imposter syndrome coming in. I think my team was responsible for the reliability of our Falcon rocket. So at that point in time, that rocket had, successfully taken cargo, satellites to orbit many times, had landed successfully, which was a huge milestone for the company in terms of proving the capability to reuse the first stage. And the focus was both on ramping up for the first human flight and then also moving towards getting to 10x reusability of the first stage. So it was kind of a two-pronged approach of, how do we take something that works and make sure that we have high confidence it's going to work every time before we put humans on top? And then on the flip side, how do we design and test our hardware so that we have confidence it's going to survive, numerous flights through extreme thermal, etc. environments as it launches and lands again back on Earth. Initially, I was responsible for, a very small piece of that pie. Each person on the team owned a particular production area, and our focus was understanding what are all of the problems or failure modes that we're seeing in this particular area, and how can we work with all of the different cross-functional teams in order to solve them.
Can you run us through an example of what that might look like?
This could range from anything like a fit-up issue. We have the primary structure of the rocket. We need to connect a secondary structure onto it, and these two pieces aren't fitting up like we expect. Why is this happening? It could be an issue with the component is not meeting the specification. It could be an issue with the hardware that's joining up the two pieces. So that would be more of kind of a simple mechanical issue to work through. Another example might be we are doing pressure testing of a particular propulsion system. So we're sending, high pressure gas in to validate that we don't have any leaks, and we're leaking somewhere. Where are we leaking from, and why are we leaking?
Just describe what a testing environment actually looks like and how you might work with another team to test the bounds and test the limits.
The kind of factory looks probably like what most people would expect. You have smaller sections of a rocket that are then joined together. So as you kind of walk through the factory, you go from smaller components to more integrated, larger assemblies, and you can kind of see the rocket physically growing in size as you integrate and build more pieces together,
Mm.
where the final stage is that test and validation. So it's trying to be as representative as possible so that when the rocket leaves our LA facility, which was the primary build site, and is sent on the highway down to Texas, where we do the first like full rocket fire test. So it's the rocket's vertical and we fire the engines for a number of seconds, that we have done as thorough of a job as we can to kind of represent that environment ahead of actually firing the engine.
Can you engage us with like your first mistake?
Ooh, certainly.
I'm just like imagining such a high stakes environment, but at the same time, you're still at the beginning of your career and human nature,
Definitely.
errors, it comes with the job. How is that sort of like embedded in the model? And
I'm thinking of a couple of examples. I'm trying to think which would be the best to talk through. And maybe I can quickly share too. Like the first example, which you kind of alluded to, is like I was a new grad with, some relevant coursework and experience under my belt, but certainly no industry experience to pull from.
Totally.
Pitfall number one, that certainly got me a number of times, and I'm sure others, is sometimes so focused on solving the problem in front of you and trying to do it as quickly as possible that you don't take a moment to take the blinders off and think about, like, this problem is happening in this scenario. How deep does this problem run? And
Mm.
how should my solution maybe address a deeper issue rather than the issue in front? And so, a specific example of this would be I discovered that our like part tracking system was insufficient, and specifically, as I mentioned before, when components are joined, the tolerance on that is very, very tight. And so you specifically will drill those two components together, then they're separated, and then they find each other later down the road in order to be joined up in the exact same configuration that they were drilled upstream.
Mm.
As you can imagine, part tracking is
Oh my
essential for that
gosh.
to work successfully.
Yeah.
I kind of discovered that some parts were joined up in the incorrect location, solved that problem, and then sort of over the course of the next couple of weeks realized that actually holistically we don't have a good way of tracking this, and the scope of this problem is much wider than I initially anticipated. And so I got a lot of help, from my manager at the time in order to figure out how to let the right people know and pull everyone together to solve the problem. But I think just taking your blinders off is something that I'm sure anyone who's early in their career has gone through a similar situation.
Yeah, absolutely. Maybe it not so high stakes, but
Yeah.
for sure.
Had some good last minute calls hours before a rocket launch with a number of people in order to decide whether or not we were okay to go ahead or not. So that was a good introduction to aerospace for a young engineer.
I can't imagine the pressure. I mean, I'm sure it's all relative to what you've been exposed to, but I mean, that's exposure therapy for sure.
Yes, you very quickly get used to it. I think your like threshold for pressure increases rapidly. So it's cool to see that.
Speaking of rockets launching, can you share what it was like seeing the Falcon Heavy with the Tesla Roadster fly into orbit?
Yes, I think that launch was a really cool. I mean, obviously, from a technical perspective, it's a huge milestone, not only the launch, but the landing in concert, which I think is also, in a lot of people's brains of a few years prior, no company had successfully landed a rocket. And now SpaceX was landing multiple rockets at the same time.
Yeah.
People were like, this has to be AI. This can't be true. And everyone internally was just so excited and proud of all the work that so many teams had done. And yeah, I think the launching of the Roadster was also just very SpaceX-esque. One of my favorite details of that launch was in the Roadster, there was a little plaque that said, made on Earth by humans, in the case that, someone would come across it in the future. So I think it had that like cheeky SpaceX aspect, but also was just like a massive technical accomplishment that the team had been working towards for a long period of time before I started.
There's something to be said about humor and how that plays into the culture and the performance of a team. Is there anything more to share there?
I always kind of felt throughout my time at SpaceX, and as you mentioned, like the stakes are very high and that results in a lot of pressure, but I feel like there is a strong culture of sort of enjoying the journey and acknowledging that things are going to go wrong. That's not a terrible thing. And how can you kind of learn the most and be as smart as possible in your decision making, but also roll with the punches. So I think the SpaceX team is extremely resilient, is probably an attribute that comes to mind that really stands out. And I think as a result of that, has achieved crazy feats, even on the tail of some pretty difficult, challenges or failures.
I probably should have checked this. I'm wondering in the back of my mind, like, what is the average tenure of a SpaceX employee? And is there something to be said about how sustainable you can make that level of intensity? And maybe like the humor is a release valve on that, but perhaps you can share some anecdotes or experiences that echo that.
Definitely. I think there is a huge level of like camaraderie within the SpaceX team. I think most people at SpaceX, their best friends also work at SpaceX. And I think that's
Mm.
because people come in quite young usually. Like the average age is low. I don't know what it is, but there's a lot of young people around. Everyone's in the same life phase. And so you get that immediate bonding, both because you're working crazy long hours, but you also really bond around like doing the impossible. I particularly experienced this, I think, when I moved to South Texas. And it was a small group of people who all decided to move to this rural town that I think none of us would have moved to if it hadn't been for SpaceX. We're working 15, 16-hour days. After we finished the day, we would all go to the same tiki bar and we would kind of all party together, go to sleep, wake up, go to work, and repeat. Felt like a cult almost in the
Mm.
best ways possible.
Mm.
Yeah, I think I look back on that life experience and I'm like very appreciative for that because I think there are a few places where you can find that.
It sounds almost like college, especially in the US, or an accelerator like StartMate.
I don't think I worked that hard in college, but
Yeah,
similar.
it's rare to have that friendship tied to a singular focus.
Definitely. And I think it is a part of everyone's identity to kind of,
Yeah.
to your point. Like, I think most people who work at SpaceX see that as like a core piece of who they are,
Mm.
which I don't think I've seen at many other workplaces, it being that tied to someone's identity.
Can you tell us a bit more about the transition from the Falcon to the Starship in Texas?
Yeah. So I, at that point, was kind of leading our build reliability team in LA. So was leading a team of, I think, 5 or 6 engineers and had been doing that for, I think, just over a year. Starship was kind of starting to get off the ground. I think they had done 4 or 5 really preliminary tests down in South Texas. All of them had failed in some catastrophic way. So they were, continuing to try to test and learn, but were running into a number of technical challenges. And so the head of kind of the SpaceX wide reliability department sort of put out an ask like, we have no one who's supporting the Starship team who's interested in joining this program. And I think everyone at the time was kind of like, this is a shit show. Like, who is going to be the idiot who volunteers to go to this rural town where they clearly don't care about reliability? They're just trying to move as quickly as possible. I think I like thought about it for a moment and was sort of like, this sounds super cool. So I think was probably the only person who put my hand up in an organization of
Wow.
who knows, probably 200, 300 people
Mm.
because to me, there was something really appealing about being sort of the first boots on the ground person to help and sort of build this team from the ground up was really
Mm.
appealing to me. So, yeah, traveled down there a couple of times. It, looked like construction site in the middle of the desert. Yeah, I think I was sort of like, this when in my life will I be able to do something like this? If not now, when? So yeah, did it. And all my friends in LA thought I was completely crazy. They were like, why would you leave LA and move to Boca Chica? But yeah, I did it.
I've got a really random question before we learn more about Starship, where you took on this, I think, a senior engineer role. I'd love to understand what you learned about reliable systems. It's a broad question.
Good question.
You're in the reliability team, and that is so transferable to all walks of life.
Definitely. I think the thing that I probably learned the most in my time there was you will never be 100% confident. And trying to achieve that is a waste of time.
Mm,
So, like, the best you can do is fully understand what the risks are and make an educated and collaborative decision to move forward anyways.
mm,
And I think that was something that was kind of drilled into me from people my senior throughout that time was we're not going to stop every launch because we have risks. We just need to do our best to understand what they are and make an informed decision that we can move forward. And I think you also, as you get more senior, need to rely on your experience and like your gut feel in that moment. There's always more information to be collected, but at the end of the day, you just have to kind of make a call and trust that. I think if you do that well, it is really powerful in terms of rallying people behind that decision.
like, what do you mean do it well?
I think like being decisively wrong is better than being unsure.
I love that. That is a big unblocker. What else?
Probably the other big lesson, which I definitely took with me when I moved to Texas, like the power of relationship building. And I think specifically, reliability is this function that sometimes, if done poorly, can be seen as a blocker. Like teams are trying to move towards the next milestone, and you might be the person who's saying, "Have you considered this? Have you?" And that can lead to, friction, I think.
Mm,
And so, like for my personality type, I think throughout my time at SpaceX, I was trying to figure out like I'm working within this reliability function, but there's a way to consider the risks, provide people with the right information to make trade-offs, but kind of all be on the same team. And so I think
mm,
when I moved to South Texas, I have an opportunity to take my 2.5 years of experience seeing where it's worked, where it hasn't worked, and like establishing those partnerships with crucial teams from the get-go so that on the Starship program, as it's kind of being built up, reliability can hopefully be seen as a team that is an enabler
mm.
to progress rather than, contradictory to fast progress.
When you talk about becoming more senior, how did the responsibilities change and what did you get right to progress like that? And maybe just start by defining what a build reliability engineer actually is.
Yes. So I should have like refreshed my memory before this call on the actual JD. I
Well,
mean,
the way that I understand it is like it's sort of like a broad quality assurance stroke, but it's far wider in its reach.
yeah, I see it as kind of like the person who is figuring out what's going wrong
Mm,
in a particular area using, data metrics in order to understand like what the problems are, what impact are they having, prioritizing all of that,
mm.
and then pulling in people from different teams across the company in order to like drive the solutions.
Gotcha. Wow. So it's this really unique blend between being actually quite awesome with people and persuasive and convincing and technical and in the weeds. Is that fair?
Definitely. I think the best build reliability engineers that I've seen have are really, really stellar project managers, really good
Mm.
communicators in that sense, but also have a lot of technical credibility such that they can also drive and own technical solutions themselves. So it's like a balance between the two.
How do you know when it's okay to be decisively wrong and when it's not okay to be decisively wrong? Is it a probability weighted decision? Like, hey, you know what? Like, there's a 20% chance of failure that this will fall down, but that is a moving ahead is far more worthwhile than not.
Yeah, I think the way that I tried to think about it was like there are two sides of the coin when you're making a decision like that. And I would always tried to be like as transparent as possible in my thinking because I think that's the best way to enable people to question you, but also buy into your proposal. The
Mm,
first is what are the learnings we're going to get from this? That's a key piece of it, right? Which is like oftentimes we're doing something for the first time. We're going to learn so much. So that's like a huge point in the bucket of let's just do it. And
mm,
then on the flip side of the coin, it's like these are the two or three top risks or things that could go wrong and the impact of that, right?
mm,
So typically it's you can break it down into like cost, timeline, like those are some of the impacts that could manifest if, say, the test article exploded. And if the learnings outweigh the risks, then you move forward. And ideally, if it blows up, it blows up in one of the ways that you expected it to. And then you move on to the next.
And what are some other operating principles?
I think a big one, which, Elon constantly repeats, and I think is in kind of the blood within SpaceX, is like simplify, simplify, simplify.
Mm,
And so it's sort of this idea of like, if in doubt, delete the part, the process, or the requirement. It's something that I've tried to really instill at Vow, which is, I think it kind of goes hand in hand with this concept of like extreme ownership and simplification, which is an example, if I'm an engineer working on the design of a component and someone from another team told me that, you know, it is only capable of operating to X temperature.
mm,
You should never like take that at face value. You should kind of like trust but verify. And you should be trying to understand like who's the person who did the testing to determine that this is actually the requirement. Because I think in so many cases, that requirement might have been established 4 years ago by an intern who did one test. If you let all of those requirements stack up over time, you're going to be over constrained and you're going to be designing a system or a part, whatever it is, that is overly complex. And so, like, do everything you can to kind of boil down to like, what are the true requirements? Who are the individual people who own each of those requirements? Getting like crystal clear on that and then like developing the right solution.
Are there other questions that you lean on that are helpful prompts for you to break a problem into its simplified components?
Definitely. I think the biggest one is this may just be reframing what I just said, but is kind of the concept of like what are the requirements? What are the reasons why we're trying to solve this problem?
Mm,
If that makes sense. I
it
think,
does.
and I just think so often people can get caught up in like, how can we improve a solution? How can we be more efficient? And so you're spending a lot of like valuable engineering brain power on optimizing something when the thing you're optimizing might be crap.
Mm,
And so all of it kind of ties back to like, how can you make sure that the smart people that you have on the team are being best utilized and are like asking the right questions so that the progress that we're making is in the right direction and is not just building on industry precedent or industry standard, which, you can still make progress, but you're not going to be as groundbreaking if you operate in that way.
Can you teach us about the development of Starship and maybe have like a particular focus on balancing the trade-offs with speed and reliability and cost?
So the development of Starship was very interesting and very complex. There were a lot of different teams involved, and I think it was like at its core, it was really how can we like learn as much as possible as quickly as possible so that we can get to orbit and learn even more things. And so it always was keeping our eye on like what is the next milestone that we have to get to and how can we sprint towards that as quickly as possible in order to learn as much as we can. And so I have many memories of us having a early prototype rocket at the build site where we, needed a week of time in order to integrate all of the last components before we physically sent it on the road down to the launch site in order to fire up the engines or pressure test the vehicle for the first time. And Elon would kind of pose challenges to the team that seemed, physically impossible, whether it was, you're telling me you need 7 days, there needs to be a rocket on the launch pad tomorrow morning at sunrise. Go.
Oh my gosh. Oh my gosh.
And while I think that is always like stressful to teams, I think it really pushed everyone to come together and be
Yeah.
laser focused on like, okay, we've got 24 hours. Let's like cut out all of the fluff that isn't needed. And it kind of comes full circle back to the requirements that I was talking about, right? Like,
Mm,
if you only have 24 hours, every team is going to be critically thinking about, like, this is the list of everything I want to do. What are the two things that are essential? And what are the 98 things that are nice to haves?
mm.
I think those were some of the fondest memories I have of, people work through the night, but then when you all achieve that, that is really a like amazing moment of both just like bonding and also reminding engineers of like, wow, we thought we couldn't do this, but we can. And it builds the confidence of the team to do the next impossible task that is coming down the pipeline.
Without a doubt. And was it sent physically after that?
Yes.
Wow.
Or what do you mean by sent?
Well, sent into orbit?
So these are more tests where we would be firing the engine for the first time. So you can
Gotcha.
imagine the rocket is like vertical on the launch pad, and we would light engines, which, is not sending it to orbit, but is certainly a high risk test.
Mm. Maybe you can shed some light on how SpaceX thought about risk.
We had a number of like really, really smart people in senior leadership roles around risk that I like learned a lot from and really, really look up to, who did a really, really wonderful job at establishing this culture of risk is never going to be zero.
Mm,
Our role here is to do as good of a job as we can to understand the risks, clearly communicate them so that it's super transparent, and then make educated decisions. As an example, in Starship days, like a really scrappy way that we would do this was basically before every kind of major test that we were doing where, the risk was we could lose this vehicle and it would cost this amount of money and it would delay the program by this amount of time, would create I think it was, I can't remember if it was 10 or 15 list of like, these are the top risks going into this test. And it was
mm,
every single team. So whether it was like structures, propulsion, kind of every technical team would collaborate. We would have this top list, and then we would have basically a risk review with Elon, the heads of different departments, and the key people. It was like once Elon was okay, and he knew that these were the risks, and we all agreed like we've taken the actions we think we need to take. There is still this remaining, risk, of course, of going into the test, but we're all aligned. That was kind of the final go ahead of, all right, we're going to go into this test anyways.
mm.
So that was like a really, I think, an example of a really like productive, scrappy way of we're going to move fast, but we're going to make sure that the right people are in the loop with the right information before we take a big step.
Obviously, when there's risk, failure can follow. What did you learn about failure?
Oh, a lot. I definitely, made some mistakes as I was managing reliability and risks and working as an engineer in test operations space. And probably the biggest learning for me was oftentimes blind spots are where there is the most risk. And more often than not, those blind spots are at the intersection between teams,
Mm.
where I think like individual teams do a really great job of knowing exactly what the risk profile is and understanding where risks are. But I think whether it's a handoff between teams or the interaction between two systems, like physical hardware systems, that is where you need to take a beat and make sure that those teams are communicating and you have the right people who are understanding those interactions, because I think that is where failure modes are hiding.
I love that. And it sort of occurred to me, maybe it's different, but like even in non-technical teams like marketing and sales, for example, when incentives are misaligned, you can have tension that boils over, both in performance and culturally. And I wondered if that was true between technical teams and whether SpaceX did a really good job of like aligning incentives. Is that a fair guess?
This is something that SpaceX did really well in my experience, and it always felt like the goals were super clear and every person was running towards that one goal. And
Mm.
I think part of it was just like it was a really transparent organization. Really senior leaders were really vocal and were really involved in the day to day. And so they were able to both initially communicate what the objective was, but then also like reiterate that and remind teams. And, if anyone noticed someone's veering off over here, it's really easy to just pull them back towards the goal. And so I think it was
Mm.
like really simple goals that were repeated, repeated by really impactful, respected leaders.
I'm also curious how, like you referred to it earlier, where it's like, hey, these are the risks and this is what we want to learn about any particular project. What did you observe about the way that teams ramped their ambition and ramped their scale? I mean, even in the first question, you talked about one of the first projects you worked on was achieving something that was 10 times more scalable. And so I'm curious, like that's quite a leap in just a project, but perhaps you can share just the ambition that you observed as the scale of things got bigger and bigger.
Again, just from my observation about how things worked, I think it kind of ties back to this concept of push people to do the impossible and they will land. I think this is another really common Elon quote. I probably misquoting it, but like, we're going to try to do something impossible and then we're going to end up being late. Goes back to like, if you give people a really impossible task, it forces them to think in a different way. And so, an example of that, right, would be traditional aerospace had never landed a rocket. Reusability wasn't really a thing. SpaceX said, we're not only going to be reusable, we're going to be 10x reusable. And I think now recently they just landed a rocket on like the 24th flight and there was a failure mode during the 24th landing. And
Wow.
but landing 24 times is a pretty impressive
Unbelievable.
impressive task. And so I actually think, to like flip your question on its head, rather than it being a like incremental, how do we go from landing once to landing 10 times? The way they approached it was like, let's challenge engineers to land 10 times. Because if you're designing or a process, a part, an organization to solve the problem, how do you land 10 times? You're going to do it in a very different way than if I told you land twice. And then when you did that, land three times. And so I
Mm.
think it's like, rather than actually scaling, it was like, what is the end goal that we want to get to? Let's challenge people to do that. They may not solve that problem. They may only get 75% of the way there. But then once we're there, then let's throw the next impossible challenge out and see how we solve that.
Mm. And I mean, there's so many similarities here with even just doing a pitch where you have your impossible mission and then the sequencing into that.
Yeah.
And I'm curious, what the timeline was for those impossible tasks.
Yeah. I mean, I think there were plenty of examples of a 24-hour timeline. I think
Mm.
leadership team loved doing that.
Did they do it with joy and enthusiasm?
Totally. I mean, yeah. There were plenty of times when it was like, by tomorrow morning, this needs to be done. And I think what made it so fun and like motivating for the team was the same person who was telling you that you needed to accomplish this impossible feat. They were on the production floor with you for the next 24 hours,
Mm.
helping you get there. I think that is also quality that I learned and saw and very much believe in is like put your money where your mouth is as a leader. If you want to drive the organizational mindset change that you're talking about, you also need to be willing to put in the blood, sweat, and tears in order to get there.
Mm.
And so because there was that buy-in across every level of the organization, it turned into more of a fun experience rather than a, here I am executing on this while they're at home sleeping.
Any frameworks or learnings that were applicable across the Falcon and the Starship?
I think I touched on a number of these things. The one thing I might add is I think another principle other than things like simplifying questioning requirements, like those are things we've already talked about. The third that I think is really translatable to so many different industries, like end-to-end ownership of things. And I think SpaceX did this probably partly through necessity and partly through, desire of rather than relying on external suppliers or kind of being a piece of the solution, how can we have more control over our own destiny,
Mm.
right? And I think that definitely is the case at Vow, which is you should kind of critically think about the partnerships or people that you're relying on, especially in industries where you need to move really fast and you need to do it cheaply. Because I think oftentimes, bringing things in-house, you can achieve a faster, better, and cheaper solution. There's risk in doing that. You're doing something for the first time. You might be, taking on aspects of the business that you didn't expect, but it means that you have a much tighter feedback loop on what's going well, what's not, and you can like problem solve in a much more productive and faster way. And so I
Mm.
think just that kind of concept of end-to-end ownership and evaluating like what can we do ourselves versus what should others be doing.
Mm. And I'm hoping my final question, if anyone asks you again, because I'm sure this is one of the questions that you get asked the most, just point them to this episode,
Yeah,
which is what was Elon's leadership like?
I honestly think that he is one of the kind of smartest and most inspiring leaders of our time. Everyone does things well and does things poorly, but I think it was cool to be in a room with him. And I think the thing that I probably took away is he is excellent at asking the right questions and knowing where to dig in. And I think for me, I was always impressed at his ability to do that at his level
Mm.
in terms of like digging into the technical details of so many different teams and his ability to kind of absorb information and then drill in to the area where things aren't going well with such low context was excellent.
How do you think he did that?
He founded the company, so I think his intuition was quite good, and he had probably built that up over time. I think he also has a excellent bullshit radar of kind of he knows when the full picture isn't being presented to him, or maybe when someone's trying to sugarcoat something,
Mm.
which is, partly a soft skill, partly knowing who you're talking to, I think. Yeah, there's also just like a technical aspect to it of having, again, built sort of an intuition, not only for like knowing what might not feel right in terms of the information that's being presented to you, but also knowing when to squeeze the lemon in terms of the assumptions that are incorrect.
I love that. Thank you for sharing. So why the heck did you go from space to cellular agriculture?
That is a good question.
Just love pain?
Yeah, yeah. Love challenge, I think, would maybe be
Yeah.
my, yeah, thought there. I think when I left SpaceX, I knew that there were a couple of things that I really, really loved about the company that I wanted to find in my next adventure. And so one of those things was working somewhere where there isn't a clear-cut solution in an industry that's really forcing the team and the company to think about things in a new way. And so I think as I was researching, different climate tech companies or companies that I felt like were really making a positive impact, cultured meat is one of those industries where there's a lot of opportunity, but I think no one has like cracked the code yet, which means that you can come in and come up with creative out of the box solutions, which was appealing.
Hmm. I love that, especially the challenges part. Let's take a step back and even just describe what the role of manufacturing entails. And like day one, what were some of the responsibilities that you had then?
So, manufacturing is really the way I like to think about it is taking a process that we've proven works at a small scale and translating that kind of benchtop process into large scale equipment and then doing that thousands and thousands of times over
Mhm.
in a repeatable, reliable way so that we can ultimately operate multiple factories around the world and produce high volume, low cost products. There are a number of different aspects within manufacturing. There's designing, validating, and commissioning different pieces of equipment and factories. There's developing the process, so taking the process that works in small scale and developing it for 20,000 liter reactors, 200,000 liter reactors, whatever's to come in our future, right? And then there is taking the equipment and the process and turning that into a well-oiled machine, which is what is manufacturing's ultimate goal, right? Is how do we create a well-oiled factory that is executing and going through all of the operations from start to finish seamlessly so that we can make sure that any customer around the world who wants our product has it on time and it meets the bar that they're expecting.
What is and why is a big reactor important to Val?
Yes, that is a good question. So it's important for two core reasons. The first is volume, right? The larger the reactor, the more product you can get out.
Mm,
If we want to be feeding billions around the world, we need a lot of product. And the most efficient way to do that is through large reactors. So there's volume and then there is cost. And if you think about it, there are many costs that compose the cost of the product. CapEx is one of those costs. The larger the bioreactor, the more product that you can get out of it, which means that the cost per kilo that you're getting out of that bioreactor is going to be lower.
mm.
CapEx doesn't scale linearly with size. There is some upfront investment when you are manufacturing a bioreactor. And so the larger the bioreactor is, the cheaper unit cost per volume of product is.
And what did you learn about building the first one that you were involved with?
When I arrived at VOW in September, I was told that our first 15,000 liter bioreactor was going to be arriving imminently, and our goal was to get it up and running by the end of the year. So naturally, that was a very exciting goal for me to be a part of.
Mm,
Our strategy for that bioreactor, which made a ton of sense at the time, was to procure it from a supplier in India who owned the end-to-end process. So they did a lot of the design work with our requirements. they fabricated and validated the system and then sent it over to us. We ran into a number of opportunities and challenges along the way. The first being that we expected to get a lot of support from this supplier during the build and validation on site at VOW. As you can imagine, this is a really large system, so it's shipped to us in small components that we need to assemble in order for us to test the system. And ultimately, that team wasn't able to get the visas they needed to come to Australia. And
No
so
way.
we turned it into an opportunity and basically
Yeah.
said, all right, we need all hands on deck here. So we brought in people from the manufacturing team, but also from many other parts of the business, from marketing, from biz ops. And we had bioreactor build parties where through the night we would have teams of people who were just assembling different pieces of hardware and testing different systems. So it was an all hands on deck experience, but I think everyone learned a lot and felt really a part of this milestone, which was really cool. And I think the second learning, which is taking some of what I mentioned previously about SpaceX, was we didn't have much control over our own destiny because we were so reliant on this vendor. And so that shaped a lot of our thinking around for our next bioreactor, what do we want to do ourselves? And what skill sets or people can we leverage within VOW in order to tackle pieces of this in the future?
Mm.
And so it resulted in us designing our next generation bioreactor from the ground up and really, really simplifying the system, as well as being a bit smarter about our supply chain strategy, where rather than relying on one supplier to deliver the end-to-end system, we could say, where does it make sense to procure the pressure vessel? Where does it make sense to procure the agitator? What about the valves? And we could critically think about who is the right supplier from a cost, but also a logistics perspective. And we, as a result of that, really diversified our supply chain for this next generation bioreactor in a way that has certainly already paid off.
Mm. It reminds me of what George said about you, and he described you as simply fucking incredible and has an unparalleled ability to get people to walking through walls over and over again. And I can see the thread from SpaceX, but how have you made it your own and maybe share an example of like what that looks like at VOW?
I think the biggest thing that rallies people to do that, in my experience, is them feeling like they are a critical piece in achieving a key company goal. And if individuals have that high sense of ownership, it's amazing what they can achieve and what they can do by, providing people with experience that they wouldn't get at other companies. And I think that's one of the benefits of VOW and SpaceX similarly is when I'm talking to people in interviews, something I often say is the level of ownership that you'll get somewhere at VOW is worlds beyond what you would get at a much, much larger company, where it does take time realistically to climb through the ranks. And each rank you climb through, you're given a little bit more ownership, a little bit more decision-making power. And I think the fact that VOW is a smaller company, it means that we expect a lot of people at all levels of the company. And so I might be asking someone who's been at the company for 6 months to make a pretty high risk decision. And so it's that balance of like high trust, high ownership, but also like support, I think. And that cultural environment breeds this really cool persistence and resilience in people.
Mm.
So I think it's partly like the culture that you create. And then the second piece is like there's no doubt in saying that when you are solving problems that haven't been solved before, every time you hit a milestone, it's like a shot of adrenaline. And so if you create an environment where people are working really, really hard. They're facing a lot of failures, but at some regular interval, they do achieve something that they didn't think they could. That sort of infuses them with the motivation to then run towards the next failure because they have confidence that they're going to see a number of failures, but the fourth time they do it, they're going to achieve something that they didn't think they could.
Related to that, like at the beginning, you spoke about all the different areas of skill sets that intersect into manufacturing. How does the team design work, and how do you make sure that everyone is in harmony?
Yeah. I think Val does a really great job of rallying around a couple of key goals. So similar to what I mentioned previously about SpaceX, I think
Mm,
George and Ellen and our leadership team are constantly reiterating what the priorities are, which means that every person at the company knows exactly where they should be spending time. And so I think what that results in is, an example, every 2 weeks we have an all hands. At the start of that all hands, we talk about priorities. And sometimes it feels like, we've talked about this for the past 2 weeks, you know, and they haven't changed. But I think while it may seem repetitive, there is value in just continuing to bring it up and reinforce these are the priorities. They haven't changed. And so, like, thank you to everyone who is pushing to achieve our number one priority. And so, by doing that every 2 weeks, I think we have really productive conversations where if any team or individual hears that list of priorities and is working on something completely different, it's an opportunity for them to immediately flag it to their manager or whomever and say, hey, I'm working on this, but it seems like I could be adding a lot more value over here. And then it's
mm.
an easy opportunity to say, yep, you're probably right, and change what they're working on.
What does it mean to be buying down risk in Val's manufacturing operations?
It is very closely linked to testing as much as possible. And I think this is, again, maybe a personal bias of mine, but you can only learn so much by performing analysis or performing calculations. You learn exponentially more by just doing the thing for the first time. And so we always are like very frequently having conversations about what is the next operation that we want to perform and how quickly can we get there? Because we know that when we do it for the first time, things aren't going to go as planned. And so
Mm,
uncovering those skeletons sooner means that we have more time to solve them.
mm,
And so, similar to at SpaceX, we'll have the conversation of what are the trade-offs, right? We could perform a sterile hold of a new bioreactor 2 weeks sooner, but that means that maybe the automation won't be complete.
mm,
And so then the question becomes, okay, the automation might not be complete. We can still do this operation manually. Do we still think that we would learn enough by doing this operation manually in order to do it? Or do we think the automation is essential? And more often than not, the answer is we're still going to learn a lot. Let's do it manually. And then when the automation is complete, we can do it again with the automation. And then that gives us two opportunities in order to uncover failure modes rather than one opportunity 2 weeks from now.
What does that mean in the context of building a factory? Run us through the scale of Val and what needs to go right.
Building a factory is, it's not an easy problem. And I think the same principles can be applied really, which is how can we learn as much as quickly as possible? And then I think another core principle is how can you understand what decisions are reversible and what decisions are irreversible so that you don't paint yourself into a corner.
Mm,
And what that means is we know that 6 months from now, a year from now, we're going to know so much more than we know today. And so what we need to do is keep our options open until we have to close them.
mm,
And so how that manifests is we decided to bring food processing in-house at the start of this year. We made that decision one night, and a few days later, we were digging a hole in the ground in our factory in order to create our food processing box. We know that when Factory 2, which is our first commercial manufacturing facility, is at full capacity with many bioreactor lines, we're going to need a massive food processing area. But in order to build that long-term food processing area, it would take a lot of time and it would take a lot of money. So what we decided is let's build a much smaller food processing area that meets what we need right now, but size certain components and make certain design decisions, knowing that over the next couple of years, we are going to incrementally increase the size of this box.
Mm. What are some of the differences between building something for an N of one or building something for an N of 1,000? Or perhaps put differently, how do you go from like R&D to production? How do you go from this is the right mixture of cells to create product Y to we're ready to scale?
There is a trade-off or two sides of the coin,
Mm,
which is performance and efficiency. And I think maybe these aren't contradictory to one another, but they are two levers that need to be pulled. And I think when you're thinking about N of one and you're thinking about, 1,000, they need to be weighed very differently. And I think when you are developing a process for the first time, you really want to understand how can we get the best performances possible in the shortest possible time frame. However, when you're then looking at translating that process into a factory environment, if getting the peak performance means that the operator needs to spin around 5,000 times and then touch the floor and do a dance, that's not going to work. And so
yeah.
you need to understand like what performance do we actually need and how can we create a process that is as efficient and reliable as possible. And so oftentimes it's okay if it's not achieving peak performance because when we do this 1,000 times, that incremental sacrifice is negligible compared to the inefficiencies that we will be accumulating.
Mm. George asked me to ask you about Mufasa from The Lion King. What the heck is
Yes.
that?
Mufasa is our 15,000 liter bioreactor. So we have a Lion King theme in Factory 2, and each bioreactor is named after a lion in The Lion King. And I think accurately so, our 15,000 liter was deemed Mufasa.
Mm. And what do you want to learn over the next 6 months?
That's a great question. I think for me, the biggest learning is probably, I'm starting to put a lot of my time and thought into Factory 3, which is our next factory beyond Factory 2. And I am starting to think a lot about higher level trade-offs that we need to make beyond the more technical. And I think it's questions around, what Val will look like when we have global operations and how can we set that team up for success in terms of where people are located, how knowledge is transferred, and how we can get and empower effective teams that aren't co-located. I think that's a difficult problem that we need to solve. In addition to that, I think there's a lot of open problems around supply chain and logistics. So similarly, if you're running multiple factories around the world, what does it look like to send product or equipment or people as needed efficiently? And yeah, I'm also always really interested in the customer side of things. So I am always trying to learn more about what consumers want in their products and how we at Vow can create and then scale products that are going to excite consumers and provide them with options that don't currently exist. And so, as much as I love manufacturing and I love technical problem solving, I also really love digging into parts of the business where I'm not an expert.
Random one. To what extent does the customer intersect with how you think about building a factory?
The customer should drive all decision making at Vow because if customers don't want our products, then what I'm doing and what everyone is doing doesn't matter, right? So everything should start with the customer. And I think once we understand what customers want and what they're looking for, it then should trickle into every part of the business. And I think it again becomes kind of a trade-off to understand what does the customer want? What does that mean in terms of the products we can produce? And then how can we produce those products in a way that is economical and feasible for us as a company?
Mm.
And sometimes we might develop products when we try to scale them, and either we run into technical blockers or cost blockers, but involving manufacturing people early in those conversations is the best way that we can prevent finding that out too late.
That was mind-blowingly impressive. Thank you for the last hour and a half.
Yes, thank you for having me.
Is there anything I should ask you that I haven't, especially as it relates to thou or manufacturing?
I don't think so, no. We're growing very, very quickly.
Mm.
And so, yeah, I guess I'll include a plug here that like we're always looking for really talented people who want to solve hard problems. And so
Is there a particular type of role?
I think we're always looking for people, like maybe two areas of particular interest is people who have experience in scale up, really. So
Mm.
and I think I kind of talked about
I
that
feel like you have.
previously. Yeah, it's
Yeah.
like people who have seen something go from the first to thousands. And as a part of that, it really is like people who have experience in automation, people who are process engineers, really any and everyone that you would expect.
Yeah, look, I'm so grateful for your time.
Yeah, thank you for having me on here. I appreciate it.
Thank you so much for joining us on this latest episode of Wild Hearts. If you want to learn from other ambitious people that are building, designing, and creating the world that we want to live in, then please hit the follow or subscribe button. It would mean the world to us here on the Wild Hearts team. We have an insane producer, Melia Rayner, an incredible editor, Andy Jones from Welcome to Day One, and our marketing and content support is provided by Jonathan Bleakley, and we couldn't do it without them. If you're searching for investment, please, my DMs are open. Find me on LinkedIn. I'd love to help. And so with that, we'll see you next week, Wild Hearts.